Now we are going to see exercise number 13. But before that, we are going to stop a little bit and let's do a little bit more theory. We are now going to study some special cases. And what are those cases? Those cases are going to be when you are going to write the general term in a different way, okay? And this is going to be for arithmetic progressions as long as they have odd, finite terms, only for this occasion, okay? So that's what we're going to be doing now. Now, we're going to see that when we have, it must be odd, okay? Why? Because we gotta have a central term. Some amount in here and the same amount in here. But we gotta have this central term right in the middle. That is why it must be odd. And for those, we can write the terms as. How are we going to write those terms? Because initially we're writing like this, like a, then a plus d, a plus 2d, a plus 3d, a plus 4d, and so on. But now let's imagine we have a 3 terms sequence. How are we going to write those terms? It's going to be a minus d, a plus d. And again, this is going to be the central, okay? This is going to be the central term. That is why it's imperative that we have odds odd amount of terms, okay? This is the only way. Well, it could be 3, maybe it could be 7 terms. If we had a 7 terms sequence, we would write like this. Again, let's put those terms in here. 1, 2, 3, 4, 5, 6, 7. Okay, I'm just trying to find the middle. Here. This is going to be the middle one. So this is going to be our A. Now you can just write the other ones. This is going to be A plus D, and this is going to be A minus D. A plus 2D, A minus 2D, A plus 3D, A minus 3D. Why are we doing this? Well, I'm just going to give you now the answer. It's pretty straightforward. The answer is when you just sum everybody, those are going to cancel, 2d minus d, and those are also going to cancel. So when we add everybody up, what is going to happen? We're going to have, in this case, 7a. In this case, we're going to have 3a. Let's suppose I tell you that when you sum up all the terms of the sequence, we get 9. The summation is 9. Well, if we just add a minus d plus a plus a plus d, those are going to cancel. So 3a, it is going to be 9, a is going to be 3. You see, the good thing about writing this way is that if we just have the summation, we just have straightforward the middle term. So it's easy and interesting depending on what we're doing. Okay, so let's write it down, but I'm not going to do on this paper. I'm going to do in another one because I don't have enough space there. So let's do it. It starts like this. Imagine. And just one thing again, the reason I just write as a, and the reason why I write as I just film, it is because I want you to listen to me and also read at the same time, okay? And it's better because it takes time, yeah, but it also takes time for you to accept everything in your mind and to process everything. I don't want just to shoot instantly all the information. Now, that's how traditional class goes on, and that's the idea of my classes. Okay. Now imagine an arithmetic progression of 5 terms, which we know those relations, which are, first, we know that if we take the 5th term, square it, minus twice the 4th term, square it, plus the 3rd term, square it, this is going to be 288. This is the first information. The second information, it is going to be the summation of all the terms, okay, going from 1 up to 5. Remember, summation of all the terms going from 1 to 5. This is going to be 235. So those are the information we have. We have this crazy equation and we have this summation in here. Now what I want you to do is find all of its 5 terms and write the general formula for AN. So that is what I want you to do. So you have to work on 2 informations. We know it is 5 terms. Okay, this is important. The 5 is important. Okay, and why? Look what we have just discussed in here. When we have odd finite terms, of course, we can't have a finite terms. I mean, we can't have odd terms if they are infinite. They gotta be finite, right? So the finite, it's not necessary. Okay, so whenever we have odd terms, we're going to write in this way. Well, we're going to write in this way because I just explained to you a few minutes ago that when we just make the summation, we're going to get something out of here. And I gave you the summation. So it's no wonder we have an odd amount of terms and we have the summation. From here, we're going to get something. Okay, I'm just going to leave in here while I talk. And from here, we're going to get something. And from here, we're also going to get something. But of course, we can't work with A5, A4, A3. This is impossible. We're going to have to change this into something else. Okay, so it's up to you to see how we're going to do it. Okay, of course, this problem, it is supposed to apply this theory. Okay, so I'm going to pause for a minute and think how you would solve it. Okay, the first thing you have to do, let's write this sequence. This sequence is going to be like this. We're going to have 5 terms. 1, 2, 3, 4, 5. The middle term we're going to call A. This is going to be A plus D, A plus 2D, A minus D, A minus 2D. Okay, you have to name them, okay, because we're going to have to apply everything here. And now it's very straightforward. Where should we begin? We could start from this information here, right? Because this is very straightforward. So let's start with the second information. The summation of all the terms from 1, this we can write like this, right? N equals 1 up to 5. And this is going to be 235, okay? And this is going to be what? A minus 2D plus A minus D, look, the terms in here, right? Plus A plus A plus D plus A plus 2D. But of course, A plus 2D with this one, they cancel. This one cancel. In the end, we just have 5A. From this, we get that 5A equals 235. Therefore, A, it is going to be 47. So this, what does that mean? Let's take a look in here. It means that 47 is going to be this guy in here, okay? The middle term, it is discovered. Now let's use this first information. Let's square A5. Is going to take some work? Yes, it will. Okay, let's do it. This is going to be what? Let's square this guy. Okay, is going to be A squared plus 4AD plus 42. This is the first information. Minus twice A4 squared, A squared plus 2AD plus D squared plus, now we are just going to add A3 squared. A3, it is just A, okay? Well, should I put 47? No, let's not put 47, okay? Let's not do it, because imagine 47 cubits, okay? Or 47 squared. It's not going to help us at all. Let's just leave it in terms of A and D, okay? Alone, only that. Well, all this is said to us, it is 288. Well, let's just make a little bit more. Let's see if there is something we can cancel. Well, we have an A2 minus 2A2. So those three are going to cancel. Can you see? Okay. Because I have A2 with A2 is 2A squared minus 2A squared. So the A squareds are cancelled. We don't have to worry about them. Now, what can we also cancel? 4AD, and here this is going to be negative 4AD plus 4AD minus 4AD, okay? Those are also going to cancel. Okay, and now what are we left with? Well, let me just do it in here. A squared plus 4AD plus 4D squared minus 2A squared. I'm just going to do it in case. Oh, this is a 4, okay? This is a 4. I'm just correcting a second. Minus 2D squared. This is 4, okay? Minus 4 plus A squared. Okay, let's see. Minus 2, and this is going to be a minus 4. Okay, now it's good. Okay, minus 2A2, minus 4, minus 2D2. Okay, now we're going to do like this. 1, 2, minus 2. That's what it is, okay? Now, 4AD with this 4AD, we just cancel. And this is just 288. The result of this, we're going to have 4D squared minus 2D squared. This is going to give us 2D squared. It is going to be 288, meaning that D squared is going to be 144. And we know that 12 squared, it is 144. So this is the other information we're going to get. And everything now is set because we have A, we have D. Now we can have our sequences, our sequence. So our sequence, it is going to be what? Let's put everybody. First, second, third, fourth, fifth term. The central one, it is going to be 47. Now, this one is going to be 47 plus 12, which is going to be 59. 59 plus 12 is going to be 71. 47 minus 12, 45, 35. And 35 minus 12, it is going to be 23. So this is our sequence, and the general term is going to be like an. It is going to be, what is the first term? This is going to be 23 plus n minus 1 multiply by 12. But look, it's not a sequence with infinite terms. It is a finite sequence with 5 terms. So we can use this equation, yes, as long as n it is equals to from 1 up to 5. Okay, this means that we can only use n for 1, 2, 3, 4, and 5. Okay, remember, when the brackets are like this, it's inclusive. When they are like this, open, okay, they are like this, then we should not consider, okay, those numbers. And that is our answer. Where is my red pen? So it will follow all of its 5 terms. So that was the mandate, all the 5 terms, and also the general formula. And please, if you just write this, it's not completely right. Why? Because if you just write this, I can put n equals 50, 100, 28, and this is, if I just plug in n equals 10, I'm going to get A10, and A10 does not belong to this sequence that I created here. So we gotta make sure that we establish that n goes from 1 to 5. Okay, this is very important. And that's it for our problem. Okay, now, oh, and this one is going to be page 25. Just like I always say, okay, sometimes I forgot to number the page, but just in case, just go to the end of the video. In the end, they are going to be there. Okay, thank you very much.